Good evening, this is Mr. Wintermelon, and this will be the worst video you'll be watching on osmosis and its effect on living cell. Why? Because I will be touching on what is negative water potential, which your O-level teacher will most likely not tell you about. So let me open the door and show you the mountain, which is the definition of osmosis. This is important for your O-level, so take out your notebook and copy the definition down. Osmosis is a net movement of water molecules from a region of higher water potential to a region of lower water potential across a partially or selectively permeable membrane down a water potential gradient. So copy the definition down, it is needed for O-level. Osmosis is a very special case of diffusion because it has three key differences. First, it is only applicable to water molecules, which is the solvent. For diffusion, it can be for other molecules, even for water vapor. But for osmosis, it is only applicable to water molecules in liquid form. So osmosis is for the solvent, while diffusion is for the solute, as well as other gas particles. Water potential is used in the case of osmosis to describe the net movement of the molecules rather than concentration, which is in the case of diffusion. And lastly, for osmosis, it always requires a partially permeable membrane, unlike the case of diffusion, where we can do with or without a partially permeable membrane. So the new kid in town is water potential. What does it mean by the term water potential? So the meaning of water potential is the potential energy of water relative to pure water. Now, some of you might be scratching your head. What does this mean? This is actually not very important. The important thing to understand is water potential is the tendency of water molecules to move from one area to another due to osmosis. It is also important to take note of what affects the tendency. So it is affected by the interaction of water molecules with other particles, gravity, as well as air pressure. But for your O-level syllabus, for all intents and purposes, you can ignore the part on gravity as well as air pressure and focus on the interaction of water molecules with other particles, which is a fancy way of saying water in a solution. When a water is in a solution, the solute will change the potential energy of the bonds of the water molecules. And again, you might be saying, what does this mean? And again, I will tell you, this is not very important. The important thing to take note is when there are solutes in a solution, that means you add some particles that can dissolve in water, it will affect the number of free water molecules. The more concentrated the solution is, the lesser the number of free water molecules. And finally, you will be asking, what do you mean by free water molecules? Don't worry, I will explain. For the case of water potential, it is actually not as straightforward as concentration. Because for concentration, I can just dissolve these solute molecules into the solution, and you can see that the number actually increased, therefore the concentration increased. So as the concentration of a solution increases, the water potential will actually decrease. But you will notice that the number of water molecules actually does not change as we dissolve more of the solute. How come the water potential decreases, but the number of water molecules remains the same? To understand water potential, you have to understand the concept of free water molecules. So I have this membrane channel down here for the free water molecules to pass through. So right now, the free water molecules can pass through the membrane channel, but If you have watched the video on solution, you will know that as we dissolve the solute in a solution, what will happen is the water molecules will start to gather around the solute. It will start grouping the solute. While the bond is not a strong one, nevertheless, the water molecules or the solvent will start to interact with it. So right now, do you think these water molecules can pass through this channel? Let's see. The channel will be saying like, no, it's too big, it doesn't fit. That's what she always said. So as we add in more of these solvent molecules, the number of free water molecules will actually decrease. Therefore, as we increase the concentration of a solution, the water potential will decrease because it will decrease the number of free water molecules. Now that we understand how water potential works, let us go deeper. So pure water at sea level has a water potential of 0. As we add in more solute, the water potential will decrease. So the higher the concentration of the solution, the lower the water potential, or the more negative the water potential, because negative 50 is lower than negative 30. Then you might ask, do I really have to know that it's negative? The answer is no, but it is very, very useful to know that water potential is in negative. Why? Right now, I want you to imagine that you have a cell with a cell set concentration of 10%. And the cell is in a 20% salt solution. Let us first talk about diffusion. Will the salt diffuse in, or will the salt from the cell diffuse out? Because the concentration of salt in the solution is higher, so the salt molecules will diffuse into the cell from a region of higher salt concentration to a region of lower concentration. Now let us talk about osmosis. In the case of water potential, we can simply add a negative sign in front of the number for us to easily tell which region have a higher water potential. Negative 10 or negative 20 is higher. Negative 10 is higher, so water molecules will move out from the cell by osmosis. Take note of how I'm describing the process. Water molecules will move out of the cell by osmosis. Because there's no verb for osmosis, that's why you have to say that the water molecules move out through osmosis, as opposed to diffusion when you can just say that it diffuses. Okay, so that's all for why we use negative. It is useful to know, and it will help you to answer your exam question when they give you the concentration as opposed to the water potential, which I assure you they will never give you. Next, let us talk about the effect of osmosis on animal and plant cell. First, let's start with animal cell. So imagine I have 3 cells. I'm going to put them in low concentration, high concentration, as well as a solution that have the same concentration as the cytoplasm. What will happen to the cell in the low concentration is water molecules will move in through osmosis and the cell will burst. And you can look at the example of red blood cell down here. Boom and boom, and the red blood cell bursts. As for the case of the cell in high concentration, what will happen is water molecules will start to move out through osmosis, and the cell will shrink, and eventually it becomes crenated. The process is known as crenation, and you can view an example down here. As for the solution that has the same concentration as the cell, nothing much will happen. So let us go to plant cell. In the case of plant cell, if it's placed in solution of low concentration, the plant cell will become turgid. Unlike the animal cell that will burst, the plant cell will just become turgid because there is cell wall that prevents the plant cell from bursting. While in high concentration, the cell will become flaccid, and in very high concentration, you will notice that the cell membrane start tearing away from the cell wall, and we said that the cell has undergone plasmolysis. And you can watch a video of onion cell experiencing plasmolysis down here. Finally, why is it important for plant cell to be turgid? Okay, being turgid allows the plant cell to keep itself firm and upright. So I have a healthy plant here. When it loses too much water, it will wilt. And to prevent further loss of water, the plant will actually close its stomata. Opening of stomata is controlled by the turgidity of the gut cell. Gut cells are the two cells that surround the stomata. So this is two gut cells, and in the middle, the opening is the stomata. So in the day, you need to take in carbon dioxide. That's why it is very turgid. It is open. Then when the sun sets, it will lose water and it will become flaccid. So this is the end of the video on osmosis. In the next video, we will learn about movement of substance using energy, and the process is known as active transport.